Hello everyone, welcome to our pre-Christmas session. Let's wait a few more minutes until everyone joins us and then we can start. Okay, let's start. Today we are going, as you can see, the agenda on the screen, and I already shared it with you as well. Today, two students asked me some questions, so we'll quickly go through them, and then we will take a look on on one practical assignment regarding the sorting algorithms. We'll just take a look on one of them, the most simple one. It's the simplest one, that's bubble sort. After that, we'll have two practical tasks related to two-dimensional arrays. It's a matrix sum and multiplication, and also a small quick task about cinema tickets. And if we have time, hopefully we'll have time, we'll start the theory about strings. We already done lots of things with string type variables, and we'll also have a little bit closer look on them. So let's start. There are two questions, and the first one was from Maya about for loops. Just quickly go through for loops, and what. So let's quickly. This one. Let's take an example. Explain it again. So, the for loops is just simple. We have four. Let's start. We have three components. The first component is we usually have integer number. We usually use I because that's most used. That's the first component. The variable which will be used in this loop. So the idea is that this variable will not be available outside this loop. That's also really important to notice. If the first one. So if we try to use this variable outside the loop, we will not be able to do it, because this is available only inside the loop. That's the first step, the first component. So I hope that's clear. Just the variable we declare and use. And also, of course, since the variable is declared, we also initialize it. And so since we are able to initialize it, we can assign any value to it. declare the variable, declare and initialize. That's the first component. So I hope for the first component it's clear. The second component is condition. So condition, true or false. And so you cannot, as I said, you cannot type any non-Boolean variable here, yeah, non-Boolean value. So just true or false, nothing else. Of course, if you keep it empty, it's considered by default as true. So if we simply, maybe let's write something inside this one just to understand the clear here. So this should provide us endless loop, yeah, because this one will always be true. So if it is empty, if it is empty, true by default. Yeah. If we write false, so this will never be executed, and you can already see it by compiler. A compiler already says it to you that because this code is unreachable. Yeah. So if you type it on the red cross, you can see that this code is unreachable, and it is already told you by compiler. Yeah, so this is unreachable code. There's no sense to keep it. And that's why it can be true or just the variable which can be true or false. So yeah, as it stands here, condition true or false. So in this case, we can add any condition which can be again true or false. Yeah. So we usually just to keep it as a cycle, we have condition, for example, I is less than something, I is greater than something. The same way we can do it if we can add even the modular or something like that. No, not true, but something like that. Yeah. So it doesn't matter any condition which returns true or false. As you know, if we compare two variables, if we compare two different values, this returns as true or false. Yeah. So condition true or false. But yeah, we usually compare the variables. And the third condition is third component is operation that is done after each loop. So yeah, maybe I missed to say it, first and second components. These are let's call them executed or checked. Checked, executed, checked. Hope you understand. Yeah, that's. So we declare the variable, of course, before the loop. Yeah, before the first iteration. Yeah, so just to get inside the loop, it's obviously we need to declare the variable, and to understand if we can go inside the loop or not, we need to check if it's true or false. That's why first two components are executed and checked. Before the first iteration, before we go inside the loop, comparing to the comparing to the third parameter, the third component, and let's put check after each iteration. So only after the corresponding iteration is done, only after that the third component, actually this is the action, yeah. So this is the action which in this case increments I by 1. In this case, again, remember I++, that's the same as I equals I plus 1. That's the same. So this is the action, operation action. Let's see. More precisely, action that is done after each loop. So after each loop, we increment, we do this action, we increment I by 1. So, and here there are 3 components. So I hope I managed to describe them as precisely as I could. Is it more clear in mind now about them? Any more questions about this? No? Yeah. Okay. So that's about for loops. Again, you can improvise and build the logic here as you want. So that's the beauty of programming, that you can improvise whatever you want to achieve your goals. So yeah, that's about the first question, and the second question was from Evita, who is not joining us today. But yeah, I will maybe show you the question, or no, even more, I will just copy paste the question. She sent me privately. So we can. Yeah, that was the question from Evita, and yeah, that's the really interesting thing about assigning initial value to string, and that's basically the part of what compilers see. In fact, for the strings, yeah, so it was about the strings. In theory, that can be applied for any reference type variable, but in this particular case, that's about the string. So as you know, if we declare string without the initialization, then compiler will show us the error, because compiler sees that the string is not changed. So we declared it as just simply as the variable, but we did not change it, and that's why we see that actually it provides us that the variable may not have been initialized. Actually, there's one maybe not stupid, but way how can we escape it? So if we maybe let's not do it now, because we'll talk about when we talk about object-oriented programming. But the idea is that if this is such obvious case, compiler will not understand. Compiler will understand that the variable is not initialized. The same as we just basically do some cases. So we have the integer, and we have and we have some value here. Then if we, as well as you remember, we can do a switch. do the switch with case, and so here we still have the issue with the string, and here we can assign the variable something like, even if the variable is initial, the value is initial, like empty string, this will also be, if we use free, for example, and here we use initial. In this case, the compiler understands that this, despite, basically regardless the value of the variable key, the code which assigns the value to variable, a string, will always be executed. That's because we have this default case. So it will go to the assignment anyway, if it's free or empty value or empty string. But actually, there's one interesting point that if we assign it to null, then it will actually be visible as non-error, because we have null value. Again, the cases when you need to assign null value and not to assign, it depends on the compiler. Yeah, if we can manipulate with it, if we can simply just use default cases and switch, or if it's if else or something like that. So in some cases, if we use again, if the code which touches this variable will definitely be executed, if it, then there should not be any error in the compilation of the program. Otherwise, if we don't have this default case, the program will compile that the variable may not be initialized. But again, that depends on the compiler. If we initialize it with null, so that's fine. That's fine, and we will not have the issue. But again, it depends on your code. In some cases, again, if you use default case, or if we do the same with if else, if equals something, the variable is free or something like that, then this is still error. If we use else, let's keep brackets, so this will result that there is no compilation issues with this code. Again, it depends on the code, but in this case the program understands that the variable will be initialized at some part of the code. If not, then we can assign the value. By default, that's fine approach. If we just initialize the string with null, that should be fine as well. If you initialize it with empty variable, that's also fine, because this is just the value. If you change the value of the string, this will actually use new object. We'll talk about strings and we'll talk about the objects, but remember I mentioned sometimes that strings but strings will actually act as the objects. We'll talk about the objects in object-oriented programming, but we already had some points about the objects, like in arrays. As you remember 3 parts: the variable, the value, the variable, the object, and the value which is located under the object. So in this case, the object string is also the object. And if we divide and the value 3, it's of course the value 3 is the different object than the value empty space. But null means just nothing, okay? Just no variable assigned to well or var. But again, the issues and the errors in the code mean that the variable is not initialized, and at some point you need to initialize it. So that's about null value. Maybe a little bit tricky and a bit complicated topic, but this is related to Java compiler. In some cases it actually acts in a little bit crazy and from my point of view not correct way, but that's fine. We can always escape it using just initialization of the variable. So that's about a null value, and right now we can implement bubble sort. So that's the sorting algorithm. So I will create a new package. Okay, maybe not. Maybe I will just use the already in the package we already created. This is oops package. So that's the common problem, not the problem, but the requirement in the programming is that we have a set of the values. Again, that can be integer values, that can be text values. Like if you have the list of people, for example, and that's usually the case when you need to sort this list, then so of course we need to think about the way how can this list be sorted. And if you simply go to just a new list, let me just imagine one list. Let it be the list of stocks. So yeah, we have the list. For example, let it be this list, and as you can see, at each column we have the option to sort. We can sort by year. So in this case, we can see already that the list is sorted. That's 1970, and in case we need to sort this list, what we need to do, or sort by this component. So we have values inside, and we need to sort by these values. Of course, the question is how to do. Basically, the first question is how to do it. How can we sort the values? Again, if it's the integer value or numeric values, like in this case, or even more, that's the text values, then the names again. And we can sort them in alphabetical order, and then we need to think about actually the way how to sort them. So basically, the question is how can we do it? How can we do it? And there are, as I already mentioned last time, there are lots of sorting algorithms. But again, the second question is, so yeah, now we know that we can do it. The question is, what's the best way to do it? Because again, if we have like the data of thousands and maybe even more millions of entries, and the entries must be sorted. So in this case, when we need to think about the algorithm which will be the best for us, which is the fastest algorithm too, the most optimal algorithm for our solutions. Again, there are two components: the time, the complexity, as we already seen last time. The complexity is mentioned for each algorithm. So that's basically the time, the number of steps need to be to be need to be done to actually complete our sorting. And there's also one more point, that's the memory. Yeah. So if we for big amount of data, and if you have again thousands, millions of entries, then for each entry, for example, you create new variable, new object, then all these take the place in the memory. So in some cases that may also be the issue, that the sorting algorithm or any other algorithm takes too much memory from the memory available. That's also the point which can be discussed when we talk about the optimal algorithms. But that's definitely not in our case, because we will not work with huge amount of data, and basically we'll just go through the basic algorithm, which is called the bubble sort. It's basically the first algorithm to learn when we talk about sorting. And what's the idea? The idea is that we have the array. Let's declare the array. Let's just simply first write the values here. Something like that. So we have the array and we need to sort it in ascending way. So how to do it? Again, the bubble sort is the way that it just simply goes through all the elements of the array. And so we start from the beginning and we compare the element with each element of the array until the end. So when we check it, when we compare, if like we compare this one with this one, so are they in correct place? Yes. Then we move ahead. We compare these two elements. Are they in correct order? Yes. Are these elements in the correct positions? No, because 8 is greater than 3, so we must swap them. So we just need to swap these two values. So now we'll have 3 and 8, and then we'll go ahead and do the same operation with 45. Then we check if 8 is less than 45, that's correct. We compare the last two elements. In this case, and again we compare if is 45 less than 23. No. Then we swap them. And maybe let's simply start with the writing this algorithm. So after, maybe I will write the comments so you can easily understand. Go for each element. Go through the array. Compare each pair of the elements. If let's call them the next element is, in this case, the next element, that's 3 and 8. If the next element is 3, the previous element is 8. Next, let's call it the current one. The current one is 8, and the next one is 3. So if the same is with all the other elements. If the next element is greater, smaller then the current one, swap them, and do the same for all the elements. And so let's describe all the steps, all the iterations for this array. For the array, first cycle. After the first cycle, let's describe all the iteration after the first loop. There will be, as you remember, we compare each two elements. So there will be 3 remains on the same place because we compared 2 elements. They are on the same place. So there will be 3, 6, 8, or 3, 6, 8, 8 remains the same because 6 is less than 8. But actually, oh no, so we swap these 3 elements and these 2 elements. So because these 2 elements are fine, these 2 elements are fine as well, but these 2 elements are not fine because 3 is less than 8, so we need to swap them. So then we swap them and 3 is in place of 8. Then 8 is here, we compare 8 to 45, everything is fine. So we type 8 and then we check 45 and 23. So we need to swap them because 23 is less than 45. So that's the first iteration, the first loop, and let's go to the next one. Second loop. So the second loop will be, we check 3 and 6, that's fine, we go to the next. Now we work with this array. We forgot about this array and we work with this array only, with these values. So we compare again 3 and 6. 3 is less than 6, so these positions are fine. We go to the next and here we see 6 is greater than 3, so we need to swap them. So then we swap them and we have 3 and 3. Then so there's 6 and we compare 6 and 8. Is 6 less than 8? Yeah, that's correct, so we write 6. We keep 6 on the same place. Then we check 8 and 23, so that's still correct. And the last iteration is correct as well. So that will be the second loop. So we already can see that our array is sorted, but the program unfortunately will not see. And so that's why the program will continue its work. So that's why let's continue. So again, we check all the elements and we see again that nothing to swap here. Not again, but in this case we can see that nothing to swap here. The array remains the same, so that's the third element. But actually one more thing. I forgot to mention that after the first iteration it will always be correct that the biggest element will be placed on the last position. I hope you can see it because if we have the biggest element in this list, that will always be swapped with all the other elements, and at the end we will see it at the last position. So actually, in fact, so after the first loop we don't need to check the last element, because after the first loop it will always be the biggest one. because again we swap each two elements. So we start with the beginning, and again we check each two pair, and the biggest element will always be swapped. If, like in this case, if we type 45 right here, for example, then it will always be swapped with all the elements which will be ahead of it, and it will be placed at the last position again. That's why it is called bubble sort, because let me check on YouTube. I hope you understand how the bubbles work. The bubbles. Let me check if there's a video on YouTube. I hope how the bubbles work. Yeah, not the bubbles or the bubbles. You have the bubbles, and you know that the biggest bubble will always be on the top because of the physical properties. Yeah, we can check. This question from Lime. Oh yeah, I missed 8. Sorry, my fault. Yeah, I missed 8. If 45 is in the first place, we can check it. We can quickly check it. So let's, for example, move it in the first position. If 45 is in the first position, then what we see? Again, we check it with 3. Is it greater than 3? Yes. Then we need to swap them. First one. Again, we go ahead. We compare it with 6. Yeah. 45 is greater than 6. So we swap them. We go ahead. 45, we compare 45 and 8. Is 8 less than 45? Yes. So we swap them again. Again, we check it with the next element. Is 3 less than 45? Yes. We swap them again. And we compare the last two elements. Again, 23 is less than 45, then we swap them again. And this will be with the big, and this means that the biggest element will always be at the last position. Because again, if it's on the middle, then you will definitely stop at it, and we will definitely need to swap it. And again, the swapped element will go ahead. So if again, like in this case, we started with 45. So we started with 45. And so after the first iteration, we go ahead with 45. Then again, we use 45 to compare to the next element. We compare it with 6. Then we again use 45 to compare, and it doesn't matter at which position 45 is. If it's on the middle, if it's at the beginning, we will always stop at this biggest element, and we will always swap the biggest element with all the other elements, and it means that this element will finish at the last position. So actually after the first loop, we don't need to compare the last element, because we already know that this will be the biggest one. That's just because of the structure of the way we sort the elements. The biggest element will always be at the top after the first iteration. The same is about the second loop. Yeah, since at the second loop we compare all these elements, it means that the biggest element of all these elements will be at the pre-final position, at this position. It will always be the biggest element of these two, because of the same reason that 45 is the biggest one at the first iteration. The same is about the second iteration. We actually need to implement the bubbling for these elements, and then 23 will always go at the top of these elements. Then the next iteration, the biggest element of these will always go at the top of them. So since in this case the bubble is the sort is already done, there won't be any swaps there, but the algorithm will check all of them. So in this case, in this case these elements are checked and the biggest one goes to the top. After the second iteration, these elements are checked, the biggest one goes to the top. During the next iteration, these elements are checked, the biggest goes to the top. Next iteration, these elements are checked, the biggest goes to the top. That's a good question. How many time the loops? The loops, there will be actually the loops for all these elements. We start with the first element, not all the elements, but all the elements minus 1, because actually there's nothing to compare for the first loop. But for all the other elements, this will be executed. So, okay, let's write the code and we'll see how it is done in a moment. So the first loop is for all these elements, the second is for all these elements, then we have for all these elements, then we have for all these elements, we have 3 more loops, and so there should be 2 more loops. For 5 and 3, that's it. Okay, so let's write the code. So again, as I said, we need to go through all the elements. That's why we start with the first element. Start with the first element, and we go until the last element minus 1. That's because there is nothing for the last element. There's nothing to compare to. So the next one is and we finish. We finish, but we increment by 1 as well, as usual. Because we go through. And it's not mentioned. So this is the length of the array. The length of the array minus 1. Minus 1 because there's for the last element there's nothing to compare to. That's why we stop at minus 1. And then, so as you remember, we go through each element. So we need to have another loop. And our second favorite name for the variable loop is j. And as I mentioned in this case, there is no at each iteration. For the first iteration, we should stop at the very last element, because we should find the biggest one. The biggest one will be found at the first iteration. So in the first iteration, we find the biggest one and place it at the last position. So there will be all the steps done for the loop. It means that so this will be the length, and for the first iteration this will be it. But after the next iteration there will be minus 1 element, because the last element is already in place. So this will be minus 1 element. So this is minus I, because I will be 1. So this will be minus I, and we can add actually the first iteration just points us it points us as how many pairs to be checked that's first one. And the second one, the last element to stop. Again, at the first iteration, as you remember, we stopped at very last element, because for the first one we actually push the biggest element to the last position. Again, at the second iteration, we already know that the biggest element at its final position. So if I is 1, then it means that we must stop at length minus 1 position. Okay. The last position to stop. So in this case, we stop at the last position minus I, because if I is 1, it means that this is the second iteration. So we stop at very last position. And here we also have minus 1. We will see why. There is also minus 1. We'll see why. Because we compare to the next element. So here we compare two elements. The current element. Yeah, here we go through all the. Of course. So the cycle which goes through the elements. Not all the elements, because again, after each iteration there will be one element less than during the previous iteration. So the elements. At each iteration. So this is, and here we need to check actually to implement this swap. Here we need to implement this one. That's why here we have minus 1, because this will actually be the last element. So the last element will be the previous element, and we compare it to the next element which is the last element. Okay. So since in the declaration of the it's called inner loop, we have minus 1. Let's put it in quotation marks, because here we have j plus 1, which will be the last element when j equals that will be minus 2. So minus 2 plus 1 will be the last element. Yes, by default, or only for this case, we don't look on last statement. We actually, so this will be the last statement. Yeah, we have j plus 1. So it will actually remove this minus 1 at the last position. Plus 1 will actually remove this. J is minus 2. So we have it. So this will be plus 1. So this will be the last position. Yeah, remember the array starts at 0. Yeah, so this is the. So here we have n elements, so this will be the element at index 0, and we'll finish at index n minus 1, if n is the length. N minus 1, So if we are here and add 1, so this will be n minus 1. And this will actually add, so here we stop at the last position minus 1, because again we have one more element which will actually be the last element, because this is j plus 1. Yeah, please think here a little bit. That's the last, so we have the element which is the previous element of the last element, and we add 1, so this will be actually the last element. We don't skip it. We actually we compare previous, so in this case we compare the current to the next one. So it means that the current must be less than the last element minus 1, right? Because we have the next one. So the next one, if we are at the end of the cycle, it means that the last element will be the current plus 1. That's why we have it. This will be checked. The last element will be checked. I mean, the last element available. Again, we don't need to check at the second iteration. We don't need to check actually the last element, because we already know this is the biggest one. So we only need to check the last element minus 1, then the last element minus 2, then the last element minus 3. So this is what we do here. And here we need to swap, and this is also a really interesting thing, how to swap two variables in Java. How to swap two elements. So to swap two elements, we need to declare another variable. And that's always the approach we always use. So this will be temporary variable. Maybe let's just simply call it variable. And we can assign one variable to it. So we assign the value of array to the current element. Then we assign the next element to the current element. So now the current element is the one which is at the next element. And for the next element, we need to give this the current value, which is the one we provided here. So, and this is it. At the end, we can print the array. We can use for each to print the element, and so this is the array. Let me just quickly print all the elements of the array. And let's not use print. Again, yeah, let's not use print line, but just simply print to store all the elements on the same line. Element. And then let's print the space. Okay, so let's see how the array is sorted. So this is how to sort it. We can type random values here. And we'll see that the sorting will work. That is so-called bubble. So again, the idea is that at each iteration we push the biggest element to the top. And again, as I said, after the first iteration, we already know that the biggest element will be pushed to the top. Then at the second iteration, the previous element of the last element will be also the biggest one. So we check all these elements. The biggest one of them will be pushed on the top. Then we check all these elements, the biggest will be pushed to the top. Then we check all these elements, the biggest will be pushed to the top. And all these elements, the biggest will be pushed to the top. Okay, I think that's maybe a little bit complicated for some of you. We will again we'll go through this case a little bit as well after the break. But now let's have the break. Okay, let's continue. So again, let's quickly go through what happens here and see. Again, what does the first, the outer loop represents? It, in fact, this is just to show how many iterations we need to go through to sort the array. Again, because to be sure that this array is sorted, we need to go through it. It's length minus 1 times, because actually we need to sort the elements starting at the second and finish at the last one, because once we stop at the first element, there's actually nothing to go through, because we know that all the other elements will be bigger than the first one. Yeah, right here. That's why we have length minus 1 iterations. In fact, as you can see here, I is used to point that we don't need to sort the last I elements. Like in the first case, we don't need to sort the last 0 elements. Yeah, that means that we need to check all the elements. In the second iteration, we don't need to check the last element, because after the first iteration, we already know that this will be the biggest one. And then then the next iteration, we don't need to check last 2 elements, because after the previous element, after the previous iteration, the ultimate element will be the biggest one. The same as with all the next iteration, which is basically shown here. We don't need to check the last I elements, and that's it. In fact, the algorithm will also work if we simply skip this minus sign. One moment, I forgot to copy. So if we skip this point, this condition, minus n, in fact, this will also work in the same way. If we skip this condition, this will also sort the array in the same way, without any issues. So the question for you, do you understand why? So, can you guess why? Do you understand why? Based on the logic we have here. Why without this minus I, will have the same result as without it? In fact, as you can see, if we have more iteration, the program will will need more steps to do. But yeah, Christine, that's correct, because actually the last I elements will be sorted. So this is basically the key point of the bubble sort. This algorithm works the same way as above, because the last I elements will already be sorted. Yeah, that's correct, Christian. That's correct. This is basically the case. After each iteration, I last elements will be sorted. And this is basically this part of the code. For the sorted elements, none of the elements will be current elements will be greater than the next element. Starting at position I. I minus 1, to be more precise. And the last question for you: what should we do? What should we change in this logic to actually sort in descending order? What should we do in this logic? And that's tricky, but so when you look at the logic here, what you can see, what we can change to sort this algorithm, sort the array in descending order. What we need to change here. So if at the moment we know that we push the biggest elements to the top, to the last position. In this case, I think you understand we need to push the smallest elements to the top. Yes, that's correct, Anastasia. We just need to switch this comparison mark to the opposite way, and that's it. Because in this case we will swap the elements if the biggest one is the next element is bigger than the current one. So this is the only change. I will also change from, we'll sort the array in descending order. Yeah. So this is basically how it works. Yeah, this is basically the basic sorting algorithm, and usually it is not used in practice. It usually is not used in practice because this is not the most efficient algorithm. Again, in this case, the worst case, here we need to, if we if we determine the complexity of this algorithm, since we need to go through the elements like almost twice, a little bit less than twice, then complexity is n in power of 2, because we go for each element, for each n, we need to, in fact it's n minus 1, but that's the same, n minus 1 in power of 2, that's in fact that's the same as O in power of n in power of 2. In fact, this is the same. That's why the complexity is n in the power of 2. That's for bubble sort. Okay, the question: why did the ball free disappeared? Because I changed it. So this is different array right now. That this was for example, and this one just the random numbers I typed here. That's just because I changed the array. I just changed the array, that's why free disappeared. And that's why. So this example is just used for the explanation, but this one is used for the testing. Alright, so the question from Natalie: why we need first for loop if we do not use I value? That's just because we need to go through we need to call this loop for n minus 1 times. So in other programming languages there's so-called thing right here. In other programming languages, there is the type of loop. It's called do just it will be n times. So it means that the cycle will be repeated n times. And so basically the fact we need to go through the loop n-1 times. That's basically the reason why we have it. We don't, that's correct. We don't use I inside the loop, but we use I in the definition of the loop, and this is what I said about for loops. So here we determine how many times the loop will be executed. This is the same about in this case. We just so here we just print. Let's start with 0. Here we just print inside the loop 10 times. So that's basically the same as here. We don't use I, but we actually use I. We use I to find out if we need to continue the loop or we just need to finish. We use I. I is used here, right here. So it's not really correct that I is not used. I is used right here to determine if we need to finish the loop or to continue. Alright, so this is about sorting, and the last two things to check to go through the arrays is so-called two-dimensional arrays. I think I already mentioned you what are two-dimensional arrays, but now let's have one practical example, and the practical example will be matrices. So we have the matrix. We have one, and the matrix is two-dimensional array. We have the rows and we have the columns. So let's define two matrices. Matrix 1. And this is the array. And this will be two-dimensional matrix. So the first row is some simple matrix with 3 rows and 3 columns. It's something like that. Accidentally. So we'll have two metrics and we'll try to multiply them. So for this purpose we will also need to use the loops. Just make it complicated. Let's start some simple values here. And now let's multiply them. To multiply the matrices, we actually will have another matrix. So the matrix will be but we now need to find the dimension of the resulting matrix. So as you remember, when we multiply two matrices, when we multiply two matrix, the resulting matrix will have the same number of the rows as the first matrix does, and the same number of the columns the second matrix. So in this case number of the rows will be the same as matrix L. So rows matrix 1, and this will be the length of the first matrix, and to get the number of the columns, this will be a little bit trickier, but yeah, in fact we can check the first element and that's the length. Yeah, for example, we can get the first element. So this is, yeah, basically we can use the first element as an option. And so to have the resulting matrix, we need to define it. So the result, this will also be two-dimensional matrix, and we will declare it right now. So number of rows and number of columns. So, and now we are ready to multiply two matrices. So now we need to go through each row of the first matrix. And for each row of the first matrix, we need to go through each column of the second matrix. So this is how we multiply the matrices. So to get through all the rows, to go through all the rows, we simply need to define the classical for all the rows. So, and in this case, yeah, and now we also need to go through all the columns of the second matrix. So yeah, this is less than columns, and moment. So that was one issue. Each rows, yeah, that's correct. No, here we have, we need to go at each element. But no, okay, I think that's correct. For now, we also need to find the number of rows of the second matrix. So this will be used for the. Okay, maybe we can skip defining them. If you want, we can also define it, but that's not what we need now. And here we'll have actually 4 loops, and we'll see why. And maybe let's start with ij. Yeah. We'll find them right here, and yeah. So as you remember, to multiply a matrix, we need to multiply each column in the corresponding row of the first matrix with each column of the each row of the corresponding column of the second matrix. So here we need to. So first we go through each column of the first matrix. The column of the first matrix will be, we can use the corresponding row and get the length. And we implement it. And yeah, each column will be. But no, actually here we can use just 3. Yeah, So this will be correct, but the length should be the same. And right now what will we do? We will the resulting matrix, so this will be zeros. So this will be initialized with zeros by default. Yeah, for integer value, for integer matrices, we don't need to initialize them. So please remember that this is important for us. Please remember that the matrices will be zeros. Will have zeros only by default. Yeah. And it means that we can increment each element. So in this case, this will be the I row and j column, and we increment it by the multiplication of the element from the first matrix, which is at I row and ij column, and we multiply it with the element from the second matrix, which is positioned at a row. Yeah, that's correct. And j column. Okay, I hope this is correct. Okay, let's check. Hope I managed to do it correctly. Oh, no, so I forgot to print out. So okay, let's print out. I will simply copy paste the same loop, and here I will print out system out print, and I will print the resulting matrix ij. Yeah, ij. I will also print the space, let's remember, just to separate them. And after each line, to go to the next line, I'll print the line break. Yeah. As you remember, you can print the line break, line separate. Yeah. Okay, I hope that's. Okay, I hope this is correct. Let's check it in the internet. Online. So you can check if our logic works correctly. Okay, I'll split the screens to just see the matrices I inputted here. Okay. And matrix a dimension, so we have three-dimensional matrix, three columns and 3 rows at each matrix. So we can type it. So we can type the first matrix is 3, 5, and 6. Then 6, 4, and 3. Then 5, 3, and 7. Second is 2, 7, and 3. Then we have 4, 6, and 3. Then we have 2, 5, and 2. Okay, I hope this. And we can see that the result is correct. So our logic is correct. So That's so now it's correct. One thing to multiply a matrix without the condition that the number of actually to be able to multiply the matrices we must provide the matrices where the number of the columns in the first matrix is the same as the number of the rows in the second matrix. So the necessary must have condition. Find the matrices number of the rows the columns in the first matrix is the same as the number of the rows in the second matrix. Alright, so I hope that if you know how to multiply the matrix in real life, you understand the concept we have here. So maybe just listen if we go through. So here we declare the matrices. I hope this one is clear. Here we determine the number of the rows of the resulting matrix. It's also mentioned here. So here we determine the length the length of the rows and columns and the resulting matrix. Yeah. So here we determine, and remember one more thing that again, if we initialize the array, it will be integer array. This will be initialized with zeros, and that's why right here we start with 0. We start with 0, and then we just increment it with new values. And again, if you remember how to multiply matrices, we need to check. Basically, we need to fill all the elements at the resulting matrix. So the elements at position I and j, this one, will be the sum of all the columns from the first matrix at the row I, at the I row. Each element will be multiplied with the j. With all the elements at j column at the second matrix. So this is basically what we do here. We declare, so here the first the first all points us go through all the rows of the resulting in the resulting matrix. The second loop is we go through all the columns of the resulting matrix. So the first and the second loop just are needed to point us which elements to be filled at the resulting matrix. And this loop actually fills, is needed to fill all the values of the resulting matrix. Yeah. At position I, j, we calculate the value of the matrix. So this is multiplication. And the sum. Let's use the same matrices here. So this will be the the more simple case is to sum the matrix. Sum the matrix. So this will be sum the matrices. So this is more simple. I think. So maybe let's. Okay, let's finish it now. This is quite simple. So to sum the matrices, must have condition. The dimensions of the first of both matrices must be the same. Matrices must be the same. So again, we need to go. So if the dimensions of both matrices are the same, that the dimensions of the resulting matrix will also be the same. Okay, so that's why we can simply, basically we can copy. I don't know, maybe let's just use the same variable, because we can also use it as well. So in this case, I will keep this loop. And I will also, maybe let's quickly write the loop for the sum again. So we initialize the array, or not the array, but the loop, or the variable for the loop. Increment it. And the same for the columns. All the rows, all the columns. And right here, so what will be the result for sum? The question for you: what we need to write to have at the result to have the sum of two matrices? Question for you: what we need to write here? This is simple, more simple. It's more simple than the multiplication. So how about the sum? Or I just need to sum both matrices. The idea is that we just simply need to sum each element with the corresponding element at the first matrix with the corresponding element at the second matrix. So right here, basically I just already said we need to sum the element ij. Where's the element ij from the first matrix? Where's the element ij from the second matrix? And this is it. This is it. So what the sums? Okay, let's have one more line separated. So we just simply sum each element. So it's 3 plus 2, that's 5. 5 plus 7, that's 12. 6 plus 3, that's 9. So the sum is correct. Okay, so this is one of the examples where we can use two-dimensional arrays, and the last example maybe maybe not more real for you, but more understandable for you will be the cinema. So imagine that we are in the cinema, and we have the rows, the seats. We have the rows and the columns. Just find the method name. We are in the cinema. cinema, and there are n times, let's call it n times m seats and rows and m columns. So we can use scanner to type how many rows and how many columns there are. Let's start with the scanner initialization. We'll use it to be able to input the values. So, and let's start. First one, let's allow user to point how many rows there are. How many rows? And we will read it from the console. This will be n rows. Let's use again next one. I prefer it. So we'll pass how many rows. This will be n, and how many columns. This will be n. And now we need to sell the tickets. So we have n times m seats in cinema, and let's imagine that we need to point which rows are already occupied, the tickets for which rows are already bought, and which rows, which columns, sorry, which seats are still available for us. So for this purpose, by default, we know that all the seats by default are available. So in this case, we can, maybe the question for you: what type of two-dimensional array will we have? What's the type of the variables we can use to point which seats are available and which not? The question for you: which variable to use? Which type of the variable to use to point if the seats are empty or occupied? Yeah, Boolean, that's correct. Yeah. That's simple, that's correct. Boolean seats, and there will be by default will be points if the seats are occupied. I want to use occupied, not empty, because by default Boolean will be false. By default Boolean is false. So all the elements of the array will be false at the beginning, at the start. So right now we can ask user to buy the tickets. So maybe we can do it this way. We'll create another method to check if there are still seats available. Yeah, so we'll create a new method which will return as if there are empty seats or not. Seats available. So we will pass the array. We'll pass the array and we will check. So basically, the first task for us will be to check if there are empty seats or not. Seats available or not. And by default, we assume that there are no seats available. False, because again we'll check. Yeah, we'll check all the seats, and if there are at least one empty seat, then we'll return true. By default, we return false. And actually, to be honest, we don't need this variable. We'll see why. We'll just simply return false. We'll see why. Because the idea is that we go through all the elements of the array. In the same way. What is the number of rows? Go through all the rows. And let me move it right here at the end. And right here I will check seats. We can use I. We can use first element. If we declare the array correct, then this should be the same. If we use I or if we use 0, then that's fine. In theory, of course, there may be the arrays when for different rows there can be different numbers of columns, as we already seen it. I'm not sure which session was it when we started talking about the arrays, but there was such case when we can declare the arrays when there's different numbers of columns for different rows. But in this case we will not have such situation. So here we implement go through all the columns, and so if the seats at position I and j is false, it means that it is an issue that we return true. So if there exists empty seat, as you remember, by default we have all the seats empty. There is this empty seat. Return true, which means that it is true that the empty seat is available. And if this case is not occurred, this will return as false. So this method will be used to check if there are seats available. Then one more thing what we can do is so we can actually print out static void, which will print all the seats in. Here we'll pass the seats, and here we will pass. Here we will print out all the seats, for the user to actually see what are the seats available. We will not return anything, we'll just simply print out all the seats, and we can do it this way. If the seat is occupied, if the seat is occupied, if the seat is occupied, it means that it is true, and then we will print X, it can be X. If otherwise, we'll print what would be O, for example. And one more thing, or no, maybe let's that's correct. And the last step is we need to add the space after each element is printed. And since we are finished with the row, right here we already completed the row, that's why we need to go to the next row, and to print it we need to add line separator. System out, but system line separator. Okay, and now we are ready to fill our seats. So here we'll have the loop, and the loop will be while seats available. While seats available, it's true. So if there are seats available, we will occupy our seats. So for this purpose, I will ask. Maybe let's start with the printing all the elements. We'll print all the seats, and then we'll ask user which row you would like to choose. Seat add, and here we will ask user to enter this row. Row entered. Then we can do scanner, and we ask user to enter this next one. We'll use parser. And the same is with the column. Which column? Column would you like to see that? And this will be actually column entered. Column entered. So now we read from the user at which row the user would like to sit. And here we check if seat at position row entered and column entered is false. It means that it's not occupied. Then we assign new value, true. And if it is not occupied, assign true. Occupy it. Otherwise it means that the row is already occupied. At this point, we can print out that this row is not available. This seat is not available. The seat is selected. It's not available. Alright, so now let's test it, see how it works. So let's have a simple example. Let's have at least 3 rows and 4 columns. Yeah, so now it printed out that all the seats are empty, and show that to seat at I would like to seat at I can leave the second row. Oh yeah, one problem here. -1, of course, yeah. -1. Because we start at 0, please remember. That will be the issue, because we start at 0. Okay. Since we start at 0, -1, since we start at 0, same scale. We subtract 1, since we again start at 0. Okay, let's run it again. And 3 rows and 4 columns. I would like to see it at yeah, that's correct. So I'd like to see it at the 3rd row, and that will be the 3rd column. So now this place is occupied. So now I can try again, and the seat we select is not available. It prints out all the other seats. I can see that first, so now it's occupied. Second, first, also occupied. Then the first, fourth occupied as well. Let's quickly occupy all the seats, and at the end we'll see that the program will be terminated. Second row, 3rd column, second row, 4th column, 3rd row, 1st column, 3rd row, 2nd column, and the last one is 3rd row, 4th column. Program is terminated. Of course, at the end we can for the program we can add that all the seats are occupied, sold out. So once the program is finished. Okay, are there any questions about this example? Again, I will share, the code will be shared, and I'll push it to Bitbucket after the end of the lesson. Any questions about this example? Okay, if no, then we can have the break now, and after the break we will continue with string. Okay, let's continue. So, yeah, there was Dr. asked to show the method. You see, it's available, so it's simple. We just go through all the elements of the array, and we check if there is at least one element false. So it means that at least one element is not occupied, and we can simply return true. Okay, that's how it can be done. Okay, yeah, but the code will be shared. Okay, more questions? Let me see. So by default you mean, or if you want one seed to be available, how do we do it? By default, or just if we occupy all the other seeds, then we'll have one seed available. Yeah, if you want to pre-fill all the seats occupied, then by default now all the seats are available. Yeah. You mean how can we sell if one seat becomes available? Yeah. So how can we change it from occupied to available back to available? Is it correct what you mean? Yeah. In this case we don't have such option, but yeah, maybe we can add the option. One moment. Let's. Yeah, we can add such option. Would you like to? Yeah. So we can have char. Option, and we can ask user, would you like to buy or would you like to return? That's an option. Sorry, that would be just text. Would you like to buy or to return the ticket? Let's type B to buy, type R to return, and here again we can use the scanner. Next, I'll use the next line, and since again this is the string, so we can return the first character of the string. So if the option is by, then we can use the same logic as we already used here. Otherwise, maybe we can use else. We can use else. In this case, it will be more precise. Let's use else if, and yeah, here we can add practically the same logic, but on the opposite way. So which would you like to return? What is the row of your ticket? What is the row at your ticket? And then again we can have this row entered as well. And what is the column at your ticket? Same column entered, and here we need to do the opposite thing. Yeah, if row is occupied, and we return, then we make it empty. Make it available. And if this row is empty, then yeah, you are a liar. This seat has not been occupied. So let's let's have a short example. Three rows and two columns. To buy or return, let it be buy. I would like to see that first, the second row and the second column. Now it is occupied, and then I want to return. This I want to return, and again second row and second column. So now the row is now the seat is available again. So we can add this as an additional option. And basically now in this case the logic will be opposite. Yeah. We check if the seat is occupied, and then we make it empty again. Alright, so let's if you have more questions, then please ask. Otherwise we can move to talk about strings. So Java string, this is a separate topic. We already have so many things about strings. Basically this topic will presentation will mostly be considered as more or less summary of the string as the type. So let's start talking about it. So yeah, as you remember, what is the string? String is not the primitive type. This is the set of characters. And as it's mentioned here, this is the class which represents character strings. So if the character is a simple primitive value, one character, one value. The string is the set. In fact, this is the array. This is the array represented in a little bit different way than the arrays usually are, but in fact this is actually the array of the characters, which is represented as text. Yeah. So in overall, the strings is the array of character elements. So in Java there are different ways actually there are two ways how to create the strings. Remember that this is the reference type. But yeah, in Java it is simplified to use it. So the string consists of multiple character values, as we already know. And char array can be created this way, but that would be, like imagine if we let's create the strings. Class. So imagine if we just declare this set of characters and want to type the name again, for example. Imagine this is not the stupid, but the really crazy way how to type the text. Of course, that would not be efficient for us to type the strings this way, of course, and that's why for Java developers there is such thing like string inventor. In fact, again, please remember that this is not the primitive type. So, in fact, there are two ways how we can declare the strings. The first way is, as we already know, simply type the text in the quotation marks. The same equivalent way, maybe it's not declared the same variable. This one is the same variable. This new, and then we type the text. So this is a string, of course. The same as above. Because again, as you remember, string is the reference variable. So we actually create new object. So this is the object. This is not the value. This is the object. The value would be the values, would be the set of the values are these characters. So the characters are the values. Each character is a separate value. But in general, this is the object. And so again, as you remember, we have variable, we have object, and we have the values under this object. So the variable, the object, and the values. The values is each character is separate value. Objects may have multiple values inside. And so these are three things. And this is the same as above. We can it's called maybe more ceremonial way to declare strings. If we simply create new string and type the values of the characters which make the string. So the equivalent way. Simple, and it is simplified for Java developers, but we don't need to call new string. We can use quotation marks and the value inside. The difference. In this simple example, the character consists of ABC, which are inserted individually. So we need to insert them individually, which is not the easiest way to work with them. So yeah, that's the difference. And basically, in this case, we just simply add each element separately. When we use the string, then we also add the same elements, but jointly. Yeah. We don't insert them. Separately. Yeah. And of course, please note, as I already mentioned, difference for the characters we use single quotation marks. For the strings we use double quotation marks, and the same is here. Maybe I'll use the comments. The A. This is the character. This is the string. This is the string, which has one element. Yeah, one element. Character A. But if we use single quotation marks, this is the character. These are the differences. Okay, so that's the difference. And as we already know, since strings are reference variables, so these are the classes. So this is the class. Yeah, again, if we let's do it this way. If we go to the string, we can type it using Control open declaration. This is the class. Right? This is the class which has some options, some methods, some attributes, some properties, since this is the reference variable. And as you remember, we have different methods. Okay. So yeah, maybe let's quickly go through the methods. The length. The length is quite simple. I will print out all the output of all the functions. So let's this one length results to I will use text str length. Just simply output. Here we can get the length of the string. 6 characters. 1, 2, 3, 4, 5, 6. The length. That's pretty simple, without any complexities. The second one is character at. Yeah, we also used it already. Char at something. We can use char 0. We already used it. The first characters returns the first character. First character, just to make it more understandable, returns the fourth character. So each character can be printed out using the char at. So, and right now, since we already know how to, just a quick go back to the loop. And as you remember, in fact, we can print out the string using the loop as well. So we can find the variable and check the length of the string and increment the let's confusing in brackets here, because here we just have one print for each character, and here we will print all the elements. All the elements of the string, or all the characters, and more precisely, that's all the string. And this will just simply return as the string. So in fact, when we print the string, we actually do this operation. We go through each character and type them at the output, but this is the simplified way how we simply print the string. This is the simplified way of how the string is printed. That's also the line break. Here. Again, we have string, but in fact, this is the simplified command of this one. In fact, all the same actions are done when we print it directly right here. But actually, the program Java does it for you. But in fact, this print is done in the same way as the above. In fact, this is absolutely the same, but the program does it for yourself. Let's try to go inside. In fact, in each object there is the method toString, which returns the string of the string. And so in this case, let's talk about it now again. So because this is related to the object-oriented programming, but actually there's the method inside the string class. Maybe a little bit more deeper than just a simple string class, but actually somewhere under the string class there's the method which basically does all these steps. Just goes through all the characters and returns you the output. So then we have equals. This is really interesting. Not interesting, but the only option we can use to compare the strings. I think we will go back to this method a little bit later, because this is basically one of the most important methods for strings. Equals, we cannot compare, please, again, do not compare the strings using the comparison operator. We can only use equals, and we will see, we already had the examples, but we will see again why. Then the method equals ignore case. Simply, if we have something in uppercase and something in lowercase, if it compares to strings, by default equals means that all the cases must be the same. If it compares using equals ignore case, then the cases are ignored, like in this case. Matches, this is related to regular expressions. This is really not crazy, but really, yeah, maybe it's also a little bit crazy topic. Regular expressions. It actually, yeah, it's these are the expressions which are placed in such brackets, which points at some set of characters which may be compared, but we'll have separate examples with regular expressions a little bit, not today, in more next session. But yes, this is also related to the strings. Actually, regular expressions do some comparisons, some checks inside the string. So if we talk about matches, like in this case, maybe let's rewrite this example. Let's rewrite this example. And yeah, I will use my string name, but I will check this matches command. Matches not from the string, and you can already see that it requires a regular expression and the argument. So regular expression, that's also the string. And the syntax, is, I think, a little bit complicated, but in Google browsing, you can browse and find the right element for your target. In this case, it actually, let's see what it actually does. In this case, it should return as true. I forgot to false. False. That's because my name is mentioned using the Latvian characters, and that's why it does not understand. If we switch it to the Latin characters, it's still it's still false. A moment. If I switch it to this, still false. Okay, something. Okay, let's check the example from the presentation. It should normally work. Okay, let's print it out. It's still false. Reset. Probably it is written here incorrectly in the presentation. One moment, let's quickly check. Basically, the idea in this for this regular expression is to check if all the characters here are the letters. So I'll quickly check. So we can quickly check the regular expression. There's cheat list. Cheat sheet. We can check this sheet. letters, so I need to, maybe that would be complicated. I'll simply just Google expression, only letters, only letters, to match only letters. So this one is, normally again this one, only letters, one moment. I think, yeah, that's basically what I already used, but why doesn't it work? That's yeah, last symbol is, I think I tried this option as well. So if it's it still falls. It's a little bit, that should normally work. That's a little bit crazy. Okay. So something is oh, maybe one moment, yeah, let's see, but that's still the, I think, one moment, I think, to check one thing. So. Moment. So if I type all the, oh yeah, so that's yeah, the regular expressions are so maybe not complicated, but all the characters must be placed here. Yeah. So that's, yeah. I think if we skip this one, that will not work as well. And that was the mistake in the presentation. Yeah. So that's the plus is forgotten. Yeah, the plus is forgotten because it actually means that we start at the first position. Yeah, so yeah, that's about regular expressions. Maybe different courses needed, and in most cases it's just like you take the cheat sheet and copy paste from it. That's not what we must usually know from the beginning till the end. It's just that's just the expressions we want to use. But the expressions are needed in some cases, especially if we work with more carefully with the strings. Like in this case, we need to check if there are letters only. If we type integer, I think. Yeah, that should not work, because again in this case we check if there are only, it will be more correct, if there are only the letters used. Yeah. If we use only the letters, this is correct. If we use any other characters, percentage mark, something else, then that would be false. Yeah. So check if only check if only the letters are used. Okay, you can check the syntax of matches of the regular expressions. This is crazy syntax, as you can see from here. Actually, in this case, it shows that you can use any letter from the alphabet, a Z starting at first position. Okay. Yeah, actually, this regular expressions may be constructed in different ways. For example, you can start at position, at third position, at second position, and check the elements. From there, you can check if the corresponding element is placed on each position you want to check, like in the third position or at the second position. You can check for if the combination, if there are combination of the elements used in the string, that can also be checked using regular expressions. But again, as you can see from here, this is really specific case when we actually need to check the string. So this is a crazy theory, which is placed in a little bit different area, but sometimes we can use it. We can use it to check the strings. We can use it to check the characters inside the strings. Right, in Java, we can do it. Yeah. So the question is, if we have the string, how can we convert it to the primitive type? Yeah, in theory, it's possible to convert to primitive type. For example, 12 to 12. If we talk about the integers, then we can convert it to the corresponding integers. For this purpose, we can use the wrapper classes, and we already did it. We already have the examples with these cases, mostly for integer. Yeah, we simply need to get the integer from the string. For this purpose, we can use parse int from the integer class. This will return us integer from the string. The same is for byte, the same is for short, and for all the other types. We already work with these cases. So as an example, if we need the character, we can use we can split. In theory, we can split the string into different characters. We can access the character we want to access. If it's the first character, the second character, and the third character, we can use the method char add. For the boolean, also we can use the boolean class, parse boolean method, which will return as true or false. Basically, the corresponding class needed for the corresponding type. And the only difference is, please note that all the classes are in uppercase, and start with the capital letter, and the full name. If it's integer, it's not int, it's integer with the full name. Integer starting with the capital letter. The short also was starting with the capital letter. The byte as well. From integer, can we do otherwise from integer to string? That's really nice. Question. There is a slide about it. We already have this format. This is what we can use. We can use the format. And this is basically, not always need to show all information about value. For example, the float value consists of 7 floating points and digits, and we can just represent only 2 floating points. But in general, before we start about, I'm not sure if we have time for today, to talk about faults, but the format. Yeah, this is basically the answer to your question. Let's just say, how can we format in the opposite way? So we can use the format method, which will return as the string from any primitive type or any other type. And for the integer, I think a moment, there's the table. I think it's not used here. Okay, one moment. Actually, as I remember, there's percentage mark on B for the integer, B45. Let's print it out. So this is integer, yeah, maybe just to make it more understandable. Let's make integer value 145 takes. We'll assign it variable, and let's see what we have. Yeah, so using the format we can assign the integer to string. Yeah. So we can use format. If we skip format, I'm not sure if this will work. Yeah, this will not work. We need to provide the format. For integer we can use D. I think default is not possible. I know that we can use D for, yeah, we cannot use for. For integers we need to use D. Yeah. Percentage mark. For integers, need to use as the format. And this can be done for faults as well. Faults. So there's an example from here. Again, so we have fault. Excuse me. Oh, yes, we're not dealing with fault. And let's have fault well string, and here we can use not percentage mark D but percentage mark F. For false, use percentage mark F, and in the end it's almost print just to clarify if everything was fine. Yeah, so now we convert fault to string, but again you can see that we have one small issue. That's the faulting point. So at this point we will see it a little bit later. Yeah, right here, how to format it. To format fault we need to type how many characters we want to have after the integer part. So in this case, if we type .2, this will return as 2 characters. two characters, two decimal points after the two floating points, after the integer part. Yeah. So this is how can we, that's the answer to your question, how can we move from integer to string. Yeah, integer we can use %d. For floats we need to use f. Let's check if it works for double. So that's double. Let's have something else. For double, let's check here, and here as well. Let's check here. And then for double that works as well. And that's just basically for all the numeric values where there are any floating points, for floating digits. For doubles, the same as for floats. Yeah, that's how can we use format. For integers, basically, there's for integers and for doubles, for booleans as well, we can use for characters. As well. And yeah, this is really interesting. This is really interesting example where we can use the parameters, the other primitive types as the parameters to concatenate in string. But yeah, this is the example which we need to have a little bit more than 4 minutes to talk about, 3 minutes to talk about. That's why I think we can stop right here today. And during the next session we'll start with this examples, this concatenation of the strings, of the strings and primitive types. So we'll continue with this one next time. For now, I wish you Merry Christmas to everyone, and meet you. So it means that now we have a small vacation, 1 week without the sessions, as you can see in the plan. So celebrate the Christmas, stay safe, and please follow all the rules we have, and so hopefully all will be fine, and let's meet next week. So Merry Christmas and enjoy your Christmas. Yeah, bye.